Hey, I'm Gulshan. I am a senior software engineer at AWS. I work with mostly on security part of AWS and Opensearch. Um, our talk today is about finding alternative to security manager. Um, Security manager is not a very famous term. You might not necessarily know about it, so we're going to talk a little bit about what the security manager was, and then at some point of time we were in a state where we wanted to deprecate the security manager. Essentially, JDK wanted to deprecate security manager, and then we went ahead and started thinking about alternatives of security manager. So that's the overall agenda. I was supposed to have Craig here, but unfortunately he's not here today. Um, he couldn't get his visa on time, so I'm going to take over all the slides myself. Okay, so this is our agenda, which we already talked a little bit about. What is security manager, and how it has been moved, how we are deprecating in 3.0. One of the very challenging part of all of this was finding trade-offs. Finding trade-offs in security is really hard, because let's say if you have something which is working well, is securing all of your clusters um, or your open source domains, and then all of a sudden you remove something. So it's really hard for us to find trade-offs, like what do you want to keep versus what do you want to get rid of. So those are the things that we're going to talk a little bit about. But before going ahead of it, let's talk a little bit about what a security manager is. So it gives you a sandboxing mechanism to sandbox your Java applications. The sandboxing mechanism was built way back in 1997, and it was majorly built to support sandboxing for applets. Interestingly, applets are no longer there, and we are in an era of MCP and whatnot. But this kind of sandboxing actually fitted very well with the plugin kind of architecture in Opensearch, and that is why it was adopted in Elasticsearch and the other in Elasticsearch and Opensearch. But JDK recently decided to deprecate all of this, primarily because it is not a very, I don't know, I don't think any one of you might have used it in your application, neither did I at anywhere else in Amazon. So it is not a very popular software. So JDK thought that it seems like it's a software which is not very popular, but it takes a lot of heavy lifting to actually maintain the software, to keep it rolling around multiple JDK versions. So it's better to get it deprecated. But that doesn't mean that it's not an important software. Like it is, or at least was one of the most. It is actually one of the first line of defense for Opensearch, open source. When you run in public native cloud or private native cloud, it doesn't. You have multiple layers of security, but when you are running your own cluster, managing it yourself, you need to have something which gives you a sense of security, and this was something that people actually loved about it. And and one of the examples of how useful this was how it prevented the Log4j vulnerability back in 2021. Like the entire, all Java applications were threatened by this vulnerability, but it was Elasticsearch and Opensearch that was just not impacted because of that vulnerability. So it gives us a sense of like how useful this software was, and then how important it is to actually find an alternative in the best possible way. Before going further, let's try to think like what this software actually used to do. The most interesting part of this software was it could help you write very granular security policies, and by granular I mean you can write security policies based upon your code jars. So let's say if you have multiple code jars or you have multiple dependency in your Opensearch code, you could say that okay, each of these jars will have different security policies. So that actually helps you to build implement principle of least privilege, saying that let's say if you have 10 different jars running in your Java ecosystem, but you want to give elevated permissions to a specific ones, but not to everyone, then you could say that, okay, yeah, I'm going to allow, let's say, socket permissions for a specific code bases, while I'm not going to allow socket permissions to the rest of the world. So that's what it actually means by principle of least privileges. Just to give you a quick example, I have it here from one of our code bases, if it is visible. So this is an example from one of our uh, plugins, which is a snapshot plugin, which, if you see here, it actually has permissions to connect on all ports, and the permission is a socket permission. It needs to, because it needs to publish your data to S3 snapshots. While if you look at other code bases, I'm not going to scan over all the code bases, but if you look at other plugins, you might not necessarily have this permission. And that is the whole jinx of it. Like, you don't necessarily need to allow everything for all code bases, but you could still have these kind of granular permissions. Okay. So this was this was a very handy software, although not very famously used, but like it served its purpose really well. We already talked about this part of it, and we also talked a little bit about why JDK attempted to deprecate it. Back in, for JDK 17, it was marked as deprecated. We thought that, okay, we have some time to find alternatives, and then eventually in JDK 24, it has been permanently disabled. But one of the other reasons is why JDK thinks is good for this kind of replication is modern softwares don't actually need this kind of sandboxing. Like, you have multiple other ways to sandbox your system. Like, you have Docker, where you could necessarily just sandbox different processes within your Docker system. You have systemd, and then these are also the alternatives that we have actually explored. You have a very cool software called GraalVM, which helps you to sandbox your applications and do applet or plugin sort of sandboxing too. I mean, we were left with no alternatives from JDK. So it was not really a surprise, but it was kind of a lot of heavy lifting for us to actually try to build something as an alternative. So, talking a little bit about trade-offs, like one of the important trade-offs that we had to take is, do we really want to find an alternative? The answer was pretty clear, at least for few of us, and we said, yeah, we do really need a replacement. And we talk a little bit about why do we really need a replacement, as when you don't run your open source clusters in cloud, then there is nothing that is securing your clusters. So you need to have something native or something that is there all the time, which actually prevents from any sort of vulnerabilities out there. And that is where the example of the Log4j vulnerability, the CV 2021-442, it actually talks about. A lot of people said that security manager is flawed. It is kind of flawed because it's really hard to deal with it. One of the reasons it's hard to deal with it is because there hasn't been a lot of adaptability. So obviously, when there is no adaptability, you don't actually improve your software. There's no point to actually keep investing in software which doesn't have an adaptability. But it was flawed. It was not flawed in what it does. It really did a great job. It was flawed in how it actually does the job. Like, you have to wrap a lot of code in something called an access.do privilege block. Then you have to put in a policy. Then you have to debug a lot of stuff. So it's really hard. It's painful for developers to actually deal with this software. That's true. And one of the reasons I think is where JDK actually went to for this deprecation path was virtual threads don't work, which is Project Loom they don't work with Security Manager. Security Manager actually works by passing context across your different call stacks, and virtual threads actually, they don't talk amongst each other. So virtual threads don't work in this kind of an ecosystem. So although it is not deprecated in JDK 21, but if you're using virtual thread, Security Manager is not going to work for you. So that was also one of the motivations why we want to remove security manager in 3.0 was Opensearch 3.0 actually brings in JDK 21, and let's say you as a plugin developer starts building something on virtual threads, is just going to break. Um, so and that was a very hard call that we took, that hey, yeah, we want to actually remove this or find an alternative for the software in 3.0, because all of a sudden we are going to start breaking plugin developers in 3.1 or line of 3.x. So 3.0, which is the major version, is a major version, is the right place to do it. Okay, so I think we have talked a little bit about what security manager is, how it was useful, and then let's talk a little bit about. So if you have to deprecate a security component and find an alternative, like for at least for our application, what were the things that are important to consider? So what we did is that we noted down all the list of things that we really want to protect the software against, and that helped us to identify what alternatives are we are gonna pick. I mean, there are a lot of alternatives out there. There are a lot of complex alternatives out there, but you cannot really build everything. And everything in time is also important. Let's say because we wanted to target it for 3.0, so it's just impossible to just do everything in, like, let's say 3 months or 4 months of time. So it went out really important for us to understand that, okay, these are the list of things that we want to protect the software against or for, and let's try to build just for these. And as time progresses, we could actually go ahead and add more stuff as people want. And these if you look at these are the most common ones that you're threatened against, right? Like you want controlled access to read write on your files and directories. Like let's say if you have certificate files on your Opensearch cluster, you don't want someone else to be accessing, or you want a very controlled access on those certificate files, right? Similarly, if you have a plugin and you want to talk to a webhook, you want a very controlled access to what ports you really want to talk to, right? So those are the things that we aimed against. And then disallowing system calls is also very interesting one. Like we don't want plugins to do a system exit for the JVM. Like that's a disaster, right? We don't want plugins to do a reboot of your JVM. Again, that's a disaster. Like, and those disasters actually come in when I mean, as a plugin developer, you are generally very honest about what you're writing about, but you never know what kind of dependencies you're actually bringing in. Like one of your dependencies might be bogus or it has bugs, and then that dependency could just overthrow your JVM all over the place, right? So those are the things that we thought that are the important ones, and we focused on these things necessarily. Okay. And so let's talk about the alternatives that we considered, and then we quickly go through some of these alternatives for that will also help you to understand like what kind of sandboxing can you do for in general for your applications. The top two ones are the ones that we picked for 3.0, which is the first one is a systemd hardening. I'll quickly talk about systemd, and the second one is a Java agent based instrumentation. We'll talk about this in a bit. Maybe a lot of you already know about systemd, but I'll still cover a little bit about those. There were two others, which is essentially splitting out all the plugins into their own separate processes, so that they don't such that they run in their own JVM, and then there are separate. Then there is a natural separation of concern between these processes, and things like a plugin rebooting an Opensearch core process is not going to happen. But and finally, GraalVM is something that is very interesting out there. You guys should go ahead and explore. We did a lot of exploration on GraalVM. It's a pure sandboxing technology, very recently built, funded by JDK. And it helps you to sandbox your application just like Security Manager, but in a very modern way. It can do all your Docker stuff, all the other individual file socket kind of restrictions, all in one single place. I see. Okay. Um, yeah. And as I said, like it was not possible for us to pick everything. So we had to take these trade-offs. Like, okay, what do we really want to pick? I mean, we went with the first two because they were the ones that were fulfilling all our goals, and within the time that we had. Out of process plugin is really great to have. There's an open PR out there to which is also an extension, building an extension, but it would have taken us like 7-8 months to build that. Like we cannot like give you an insecure product just waiting to build a fancy product, right? GraalVM sandboxing, we did a POC, and then there is a GitHub link out there. It was a very interesting POC that one of our core maintainers did. But there was a very honest decision that we took, that this is going to add a lot to our software. Like there were a lot of plumbing, at least for our software, that was required to support GraalVM. So that's why we dropped those two. We may come back and explore those two again, but at least for now, the first two are the ones that we got to focus on. Apart from this, when we are building any new component or introducing any new component, our goals and performance are like really, like we need to raise the bar on performance, and then raising the bar on performance essentially means that you have zero overhead of performance. um, I mean, you could also say that you may have a minimal overhead of performance, but our goal was generally to have zero overhead on performance. And then if you get in like 1% or 0.1%, 0.2% here and there, it's still fine. And again, the other important thing is zero breaking changes. Like if you're moving from 2.19 to 3.a as 3.0 as a plugin, as a user, you just don't see the transition. And that's true. Like you just don't see what has changed in the underlying software. You shouldn't be complaining that, hey, this API used to work, but now in 3.0 it doesn't work just because of security. And we'll talk about how we achieve those two things. System D hardening. So system D is let's we talk about a little bit on these. Okay, so what is System D? System D is essentially a service manager for Linux ecosystem. What it does is it's a service manager to init your processes. So you could say that you define a set of configs in your init process, and then you say that this is a System D unit, and it starts your processes with those basic configurations. And you could do crazy number of things with those configurations. Initially, when System D was, I mean, I might be wrong, but initially when System D was built, it was mostly to manage your process, like execute some executables at the start of the process, or um, um, limit or enforce a limit on memory, or enforce a limit on CPU usage. But over the years, it has evolved like crazy, and it now has like so many a set of security features which you can say that, okay, I'm going to start this process, but when I start this process, I'm also going to start this process with set of rules which says that my process cannot do more than what it is supposed to do. And we'll see some of those those interesting configs. The crux of the point here is what you're doing is you're saying that, hey, operating system, do security for me. Previously, what we were doing, like we were writing a lot of applications, and then we said, okay, I'm going to do security myself. But at this point in time, what we are saying is that, oh, the operating system can do a bunch of things for you, so why not delegate the operating system to do all those things? I mean, it is still, I mean, you cannot still let operating system do all the work, but try to do. But the goal here is like whatever operating system can do for you, just try to do that. And then we'll come back to the Java agent in a while. We already talked about why GraalVM was dropped in. No complaints about GraalVM. We worked very closely with GraalVM folks. They were like so supportive for us. But it was just not, I think it was just not ready for us at that point in time. But as developers, I think if you have heard about GraalVM in this talk, you should also actually go and explore that area. It's really interesting. Okay, so I'll come back to the full view of the slides again, but let's take a look at some of the systemd configs that we introduced as part of this project. Okay, so our systemd config used to be very dumb before this transition, and I don't know why it was dumb, but when we started looking at this when we started looking at this software component, we felt that we could actually leverage a lot of things which is out there for systemd hardening. And I'm not gonna, I have only 5 minutes left, so, but I'm just gonna skim over through some of the systemd configs which were really useful for us. And let's take a simple example over here. This guy actually tells you that you cannot, let's focus on this guy. This guy actually tells you that any other component within the process cannot reboot or do swaps in the system, right? While this guy says that, hey, while other processes cannot do swap in the system, they are still allowed to do some native calls like madvise or mlock. And those are actually required for the software. And similarly, you could build different other sort of capabilities let's say about this. Let's talk about this. Like, you are not allowed to do capnet admin or sys trace. Like, those are the restrictions you could just enforce at operating system level. Just to give you a quick idea of how things changed in terms of security. So the previous exposure that we had was was 8.8, and after all these changes that we made, the exposure to the software is 4.6, which is pretty nice. I'm just gonna skim over to the next slides because we have little less time left over here. But what I'm trying to say is, by overloading or leveraging the operating system, you could do a lot of stuff. Okay. Talking a little bit about the Java agent that we introduced, which is also very, very interesting. One of our core contributors, Andrea, credit goes to him to build all of this, design all of this in a very quick span of time. What Java agent is like, it's a special software which allows you to inject a bytecode in your Java applications. And this injection of bytecode could actually intercept some calls and then take actions like what do you really want to do via those injections. ByteBuddy is something that we use as a software for this sort of an injection. But let's quickly go through some examples on how do we leverage this injection. So if you look at this, I don't know if it is visible. But if you look at this example, what we are trying to do, let's try to take a look at this example essentially. Okay. So what we are trying to do is we are trying to intercept connect calls in the software, and once we have intercepted a connect call, what we could essentially we could do a bunch of things on the connect call. It's upon us what we really want to do on the connect call, right? This is the example of intercepting a connect call. And similarly, if you look at these intercepted methods, like these are the examples of intercepting on various file operations. So with the Java agent, what we really did is that we said that, okay, we are going to build two instrumentation APIs, one to intercept socket and the other one to intercept file. And we are just going to say that no other software, like only allowed softwares are actually allowed to do file and socket calls. Let's dig into the next piece of it. Is okay. So once you have intercepted a call, what do you really want? What do you really do with that call? So what we do is we stack walk the entire trace, and then we find out. Then we look at all the classes in the stack walker, in this walked stacked, and then we evaluate that whether classes, or essentially it's called a protection domain, whether these classes in this stack call has permissions to do specific calls or not. For example, in this particular example, what we do is we do a stack walking. We collect all the protection domains in the stack walking, and then we match it against a policy. And if you remember, this is a policy which is very much similar to the policy, the JSM, the security manager policy that we showed in the earlier slides, which is where backward compatibility comes in. So we match it against policy and say that only if you're allowed to, only if that code base is allowed to do a socket or a resolve call, only then you could go ahead with that go ahead with the next steps in the call stack. And the moment you actually find that there's something as a deny listed in the call trace, you just denied the entire call. So all in all, what you the jinx of it is, in order for you to make a socket call across multiple layers or across through multiple stack traces, all the stack traces should have permissions to do those correct calls. If they don't have, you just fail. I'm gonna stop here because I think we have very less time left. But if there are GitHub links out there, so you could go ahead and look at it. There's a very interesting truth table out there which actually talks about like what things look before versus what they look now. With this, I'm gonna end my slides. Thank you.